Hi, Papa here. Today's video is about how granite forms. And I'm going to be using the book to show you some pictures out of the book. Here's the book. It's called The Rocks of Georgia. And you can find it on Amazon Books. Look it up, and if you like the reviews, you can buy this book. It tells all about how the rocks of Georgia are formed in a simplified but accurate version that you can understand. And it also has really good color photos of almost all of the major rock types of Georgia and the eastern United States to help you learn to identify them. So we're going to a page in the book. Okay, this page shows you Earth's giant crustal plates. You can see the continents. All the continents, which are in yellow, are made of what we call land crust. Land crust is mostly granite rock. It's other kinds of rock, but mostly it's granite rock and metamorphic granite rock, which is called granite gneiss. And then the red lines outline the giant crustal plates of the Earth. And let's look at this one right here. Okay, that's the African plate. And you can see that it's made out of land crust, which is the land mass of Africa, but it also is made out of ocean. So down there on the bottom of the ocean, there's what we call ocean crust. So almost every single one of the Earth's giant crustal plates is made out of a combination of land crust, which is mostly granite type rock, and ocean crust, which is mostly basalt lava rock, which is very heavy and very dark. So land crust rock is mostly granite. It's lightweight, and it's also light colored. Ocean crust rock, which is made mostly of basalt lava, is dark rock, and it's very heavy rock. Okay, so it looks kind of like this from the side view. Here's this blue that's the ocean. Up here is the sky, and this is the side view. Okay, this is a piece of one of the great crustal plates. So you have the land crust part, which is here, mostly made of granite gneiss and lightweight, light colored rocks. Here's the ocean crust part, which is made of heavy, dark, thick basalt lava kind of rock. All these crusts, land and ocean crusts, are riding on top of a gigantic cauldron of hot molten rock called the mantle. It's not liquid. It's because it's under such pressure. It's extremely hot, but it's like Play-Doh, plasticky, and it moves around, and that's what causes the plates to move around. And really, the Earth's crustal plates are just the cooled top of the mantle. All the elements that make up all of our rocks are floating around in this Play-Doh, plasticky hot mantle. And when they come to the surface and cool, when they cool and then come to the surface, or come to the surface and cool, then they make the rocks that we see all around us. Okay, so what does this have to do with granite? I will tell you right now. You know, I said these crustal plates are moving around all the time. They are because of the hot convection currents in that mantle. You know, the heat comes up from below, and it can break continents apart. That's called rifting. Or it can break an ocean apart, and that pushes two continents together. So we're going to talk about two continents being pushed together. We said that continents are land crust, made of land crust, and that's mostly granite. It's a light colored, lightweight rock. And that's why it always floats to the top and becomes land crust. Okay, so these two giant land crust continents, let's say United States of America and Africa, are coming together, which they actually did about 300 million years ago in the Alleghenian orogeny. We'll talk all about that later. They're coming together. The ocean crust that's in between them goes away by a process called subduction. We'll talk about that later too, but just know that it's the ocean crust is diving down into the mantle, and these two giant granitic land crust continents are coming together. Well, they hit, and this big continent rides up on this one and pushes it down. So whatever rock is most of the granite and other kinds of rocks that make up this land crust get pushed down into that hot molten mantle, and they melt also. And so new rocks are reforming. And one of the main rocks that reforms is more granite. Later on, this continent erodes all over this one, and they both become flattened out now because they're all eroded even, which is what nature always tries to do. So they're eroded even, and slowly but surely all that granite rock that was made when the first continent pushed into the second continent is cooling down there. And if it cools really slowly, that gets bigger crystals. And if it cools fast, it gets smaller crystals, and that's how the granite forms. Now, there was already granite in both of these continents. What happened? Some of the granite got melted and turned into more granite. But some of the granite, when this happened, got only partially melted. And when it was partially melted, it turned into our next rock type, which is called granite gneiss. And that is metamorphic granite. Granite that has been subjected to metamorphic processes. Continents crashing into each other. That's metamorphic process, one of the several. Okay, I hope that made sense. And eventually I'm going to learn to look at you instead of the guy in the video. Anyhow, I hope that made sense, and have a great day. Papa out.